So what we'll be doing with calculus is we model rates of change. We're looking at some situation that's continuously changing over time. And what calculus allows us to do is to find rates of change. Without calculus, we could always easily calculate the average velocity or an average rate of change, just as we did above. With calculus, what we're going to be able to do over the next couple of days is find what's called the instantaneous rate of change. Maybe I should have said we can find. We can find. Instantaneous rates of change. And that's, again, what we're working toward. We have two branches of calculus. The first branch of calculus, this Unit 8, is going to be differential calculus. Differential. And then if you've looked ahead at our yearly planner, you'll see the next unit, Unit 9, will be integral calculus. And those will be the two final units of this year. Next year's last unit of the whole course will be called differential equations, which will actually combine both of these units together as well. And the idea, some of the basics of calculus. So our course doesn't go much into the idea of limits. Even the analysis course does a little bit more than we do, but not a lot. But if you do take university level calculus, which most of you will, you'll actually have a lot more deep dive into limits and what they mean with calculus. And we'll look a little bit more at it, but we're just going to, in this course, look at a very general idea of a limit. And so our definition of a limit is when a function becomes arbitrarily close, very close to a unique fixed number, L, which is the limit. L is the limit. As your x approaches a specific value or approaches something from either side of that function, then we can say that the limit as x approaches that value is L. This is a little bit confusing, obviously, in words. Notation-wise, it's written like this. Limit as x, or the limit of a function f of x, as x approaches c is L. So this would be said the limit of f of x as x approaches C is L. And notice that, I think you should notice that limit and f of x and equals L are all in the same line in the same size. So that's like one line on your paper. And right below that is where you write x approaches C. And it goes only underneath the lim part, not underneath f of x. So it should be the limit with what the limit is, or what x is approaching, directly underneath lim, then f of x, and then equals L. And that's how we write that.